Hey, what's going on, guys? It's Ilya here. I do coding stuff on YouTube. Check description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel. Give me a big thumbs up to support it. And this is called balance a binary search tree. Given a binary search tree, return a balanced binary search tree with the same node values. A binary search tree is balanced if and only if the depth of the two subtrees of every node never differ by more than one. If there is more than one answer, return any of them. Let's look at this example. We get this unbalanced tree and we return this balanced tree. 2 corresponds to 2, 1 corresponds to 1, 3 corresponds to 3, null, 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 and 4. We could also return 3, 1, 4, null, 2, null, and null. The number of nodes in the tree is between 1 and the base 10 raised to the power of 4. The three nodes will have distinct values between 1 and the base 10 raised to the power of 5. Well, I'll show you how to solve this problem recursively. All you need is the list of the type tree node, list new array list of the type tree node. Next, we will be doing the depth first search in order traversal. First, we go left, then when we reach the leftmost node, then we visit its parent, then we go right, again we go left, and when we reach the leftmost node, then again we visit its parent, then we go right, then we go left, and so on. We call this helper method. To do that, we pass root, then we should return the construct, also helper method. We pass 0 and the list dot size -1. We will be doing something very similar to binary search in order to construct this balanced binary search tree. Okay, here implement this helper method. Tree node root indicates when the root is null, then we return. There is nothing to do with that. We can also do that iteratively. We could use the stack data structure, but I think this recursive is also good and short. So we go left, we pass root dot left, then list dot add, we add the current node, which is the root to that list, and we go right, we say right, and we implement the construct method, which returns the tree node, returns the root, int start and int end. In the case when the start is greater than the end, then we return null. otherwise. In regular binary search, we find the midpoint, and in the case when the value which we want to find is less than the value at the midpoint, then we go left, otherwise we go right. Or in the case when the value which we want to find is equal to the value at the midpoint, then we return this midpoint. Here we do almost the same approach in order to construct this balanced binary search tree. We find the midpoint, which is the start plus end minus start divided by 2 to prevent an integer overflow. We create the tree node, which is the root, and we get the node at the position of the midpoint from that list. Then we say root dot left. We go left. We call this method recursively. We pass the start and the midpoint -1. Root dot right is equal to construct, and then we go right, left and right, and we say midpoint +1 and the end. Finally, return the root. That's it. So what do we got? We got this list. We call this helper method in order to do the depth first search in order traversal. Then after, right here after this method, when we enter this method, we have this list in ascending order, which is sorted in ascending order. That's why we do things which are similar to the binary search. In the case when start is greater than end, then we return null. Otherwise, we find the midpoint, we create a new node. We got that node from that list at the midpoint. We go left and we go right. Finally, we return this root. For example, we could return 2 or 3. Yeah, that's pretty much it. Let's run this code. Accept it. Let's submit. Good. Thank you guys for watching. Leave your comments below. I want to know what you think. Follow me on social medias, on Instagram, add me on Snapchat. Give me a big thumbs up to support my channel. If you need some help, please again leave your comments below, or you can contact me directly. I'll see you next time. Bye.